Hello! In this video I will show you how I made this custom heatsink using 3D printing, a desktop CNC router and a vise. I made this test piece because for an upcoming project I need to build a large heatsink with multiple heat pipes. However, before tackling the full-scale version I thought it would be wise to start with a smaller, simpler model to test the process. This is a typical aluminum finned heatsink with copper heat pipes. The heat pipes transfer heat from the hot side to the cold side, where it spreads into the fins. The heat is then dissipated into the air, usually with the help of a fan that pushes air between the fins. The challenge here lies in the precise dimension and tolerances at the interface between the fins and the heat pipes. The sheet metal is thin, and you want to maximize the contact area while keeping a low profile. This requires tight bending and tight fitting on the pipes. So the question was, can the sheet metal be formed at this scale using dies made from resin on a low-resolution printer? The outcome was uncertain because resin-printed parts are quite brittle, and durability was also a concern. For a heatsink designed for a 40mm fan, you need about 20 fins. With a 90mm fan, you need roughly twice as many. So another question was, how many fins can you press before the die gets damaged? These are some of the questions I aim to answer with this test piece. So before going into the details, let's have a quick overview of the process and tools I used. For 3D design, I use FreeCAD, a powerful open-source mechanical CAD software. It is organized into workbenches, each tailored for specific tasks like design, simulation or manufacturing. Later in this video, I will show you two quick tutorials on the part design and CAM workbenches. The fins were cut from 0.5mm thick aluminum sheet using a CNC router. I prepared the job in the CAM workbench and exported the file in GRBL format to be cut on a Genmitsu 3020 Pro Max V2. This router has a 300-watt spindle which provides sufficient power for working with aluminum as long as the step-down and feed rate settings are kept light. For this test, I used 6061 aluminum alloy because I had this alloy in stock, but for heatsinks it is better to use 6063 or 1050 alloys, which have better thermal conductivities. The stamping dies were created in the part design workbench and then exported to Litchi Slicer. They were laid flat on the printer bed to ensure the feature remained straight. I used the Creality Halot 1 printer, which has a 50 micrometer pixel size. While it's not the latest model or the highest resolution, it was sufficient for this task. I used the standard 2.0 grey Elegoo resin, which has a hardness of 80 to 86D, and the prints were cured under sunlight. The STL file for the assembly tooling were exported to Ultimaker Cura and printed on an AlphaWise U30 Pro using standard PLA. Although the printer is not the most recent model either, it is still capable of getting the job done. Finally, the sheet metal forming was completed using a Vevor vise, which provides up to 2 metric tons of clamping force. So let's dive into the design with FreeCAD. You can see each steps of the project: a fin, the vise and the stamping dies, a die release tool, the manual assembly tooling consisting of a pipe holder and a fin stacking handle, and the final heatsink assembly with a preliminary pipe clamp. First, I made a 3D version of my vise and then I designed the fin and the stamping dies. I thought I would create attachments for the jaws to hold the dies in place, but in the end I decided for this test to hold the dies by hand, so I added a little tab on one side. We can switch to a 2D view of the fin and the dies made with the TextDraw workbench to better see their dimensions. The heat pipes I am using are 6mm in diameter. For good thermal transfer between the pipe and the fin, a large contact area is needed between them. I thought that 1mm would be okay, so I made the bending radius 0.5mm. This makes the fin 2mm thick. I chose to test a 5.9mm inner hole diameter. There are guiding elements to align the dies, and I added a wedge for a gradual bending of the metal sheet. However, as you can see, I did not make any drafts that could help release the stamped fin from the die. I did a first test and the sheet metal was hard to remove from the die, but the bending was good and the fit with the heat pipe was tight enough. I decided to keep the face straight to keep this good mating with the heat pipe. So I made a die release tool consisting of small rods that are pushing the back of the fin through the die. As we will see later in this video, it worked, but most of the rod broke in the process. But I did manage to finish the batch of 20 fins. Clearly, I made the rod obviously too small, although there was enough space to make them larger. Anyway, it probably can be done without this extra tool by using a small draft on the die, but that will be for another test. Then the assembly tool is meant to hold the heat pipe parallel while the fins are being stacked. I overlooked the hole's diameter on the pushing stacking handle. I made them 8mm, but it was probably too wide. The tool could tilt more than would have been optimal. Anyway, for a larger version I will probably stack the fins using the vice and guiding elements between the assembly parts. Then there is the final assembly, which I can export to any other project in FreeCAD if needed. So if you are new to FreeCAD, let me show you how to quickly design the fin for use in a 3D model and then another one for use in CAM to create a job for the CNC machining. So I created a new document. I go in the task panel, I create a new body, a new sketch, I select the XY plane, I make a rounded rectangle and set the dimension either using keyboard shortcut L or the toolbar. Here I'll use, for example, the toolbar, 20. I make a symmetry to the origin. I press S and I make the radius with R 5mm. I close. I make a pad 0.5mm. I select the top face, create a sketch, make a circle, set the diameter to 6.9 and at a distance of 10mm. I close, I make a pocket. Now what I want to do is create the bending, so I need to add a datum line. I create a datum plane and I constrain it on this edge and on the datum line. So this plane is on the hole. I create a sketch which is on the datum plane. What I want to do, I close and I hide the datum plane. It's still here, but it's not visible. And what I want to do is change the transparency so that I can select more easily the edge of the hole. I can at the same time rename the body fin. I go back on the sketch and what I want to do is select this edge and project it on the sketch, and I can see it through the part. Now I want to do the 0.5mm radius bending. I need to close the shape so that I can make later a revolution. Here I switch to construction line. I make one line horizontal and one line vertical, so I make it horizontal, here vertical, and this one I want to constrain the point onto the object. And here I set diameter of 1. Here it shows diameter, but I could set it to radius, and you see it's 0.5. I close, and now I can make a revolution. So I select the sketch, the datum line, and here I make a revolution. I select the reference. Okay. Now I can select this face, make a pad of 1mm, And here I have one hole. I can hide the datum line. And now if I make a symmetry, I know, first I select what I want the symmetry. I want the pocket, the revolution, and the pad. And I make a symmetry. It selects automatically this plane, so I'm okay. And that's it. I have a fin to be used in a 3D model. Now let's see the difference with the fin needed for the cam design. So to prepare the fin for the CNC, the process is a little different. Again, I create a body, I create a sketch, I add a rounded rectangle, I set the dimensions, I set the symmetry. Now the difference is that I add 2 circles. I set the dimensions to 3.8 millimeters and I set the spacing to 20 millimeters. The sketch is green, it is fully constrained. Now I make a pad of 0.5 millimeter and that's it for the pin. I can rename it pin. And now we can switch to the cam workbench to prepare the job for the CNC. So I create a new job. I set the stock dimensions to the sheet metal I have, 160 by 130. I set above and below 0 millimeter, and I want to set the origin in this corner. I want to output the job in GRBL, and the tool I will set it through another interface. So I can hide the original model, show the stock. Now I can add a tool. I already created a single flute end mill in Carbide. I double click to add it. I remove the default tool. I change the spindle speed to 11,000 RPM. I set the horizontal feed rate to 100 mm per minute. 70 for the vertical. I go in the setup sheet to set the velocity when it's above the workpiece. I set the same velocities, although I could go faster. Now I want to select the top face of the pin and select the profile operation. I set the depth. The top face is selected, donc the start depth is 0. I select the bottom face and we see it's 0.5 mm, but I want to add an extra margin, so I will set instead 0.6 mm. I select the step down to be 0.2 mm. I can apply to preview the operation. We see that there will be 3 passes, but the holes are not made, so I process circles. I apply, and we see the tool will go in the circles. And that's it for the operation. Now, one more step, I can close the tool selector. One more step is to multiply this operation to have an array of pins. I created an array. I can modify to be a linear 2D with 3 copies on X, 4 copies on Y, and an offset of 44 and 24 millimeters. And that's it. I have defined the operation. I can go in the simulator, I run, and we see that the tool correctly executes the operations. I can stop the simulation, and then the step is to post-process. So I post-process, I select a location, and it opens the report where I see all the commands which will be sent to the CNC router. So the fins are fully stacked. There was quite some resistance when stacking the fins, which is good, but there was a risk of pushing too hard and of the fins slipping and going too far. It would not happen if the stacking was done using the vise. That's what I will do in the next design. In the next design, the heat pipe won't be straight, and it will have much more resistance because it will be using 6 heat pipes. Also, it will be for use with a 90mm fan, but the vise only has an 8.8 cm opening, so it will require a special fixture on the vise to correctly stack the fins. Anyway, I will show that to you in a future video. For now, I would like to thank you for watching this video. I hope you found it interesting and that it can be useful for you. If you want to see more or want to support this channel, please consider subscribing, putting a like and telling your friends about it. It will definitely help me get started. So have a great day and see you soon.